Now we're going to examine Turing machines that do not halt. What does that mean? Halting means that either we have found a string which somehow leads us to a halting state, which can either be an accept or it is a reject. Now, a Turing machine does not have to halt. Now, it also does not mean it's stuck in a loop. So let's take an example. Suppose a Turing machine tries to find a counterexample to a famous Goldbach's conjecture, which says that every even number, at least 4, is a sum of two primes. What does that mean? That means the Turing machine is going to try out every value of even n in increasing orders. So for each n, it checks whether there is I such that both I and n minus I are prime. So you take the two numbers and they must be primes. And when you add them up, you find the number n. If that does not happen, it stops. Otherwise, it's going to continue forever. So basically built a Turing machine that we humans are not going to find out if it's going to halt or not. As a practice, we look at this example. In this case, the alphabet is 0, 1 and 2, and we want to find the strings, which is a concatenation of zeros raised to power n, 1 raised to power n and 2 raised to power n. You can look at the solution for this practice and try to implement it in JFlap and test it out. In this case, we are using extra symbols like X and Y. So when we start out, we see if we got a 0. In that case, we write a delta and move to the right. Or we got an X, in which case we let it be there and then move to the right. And then we also move the states. And this keeps going till our problem is solved. So to summarize this chapter, a Turing machine is just like a finite automaton, but it has an infinite tape. The input starts on the tape, it's surrounded by blank cells denoted by, say, delta or any other thing which you want to represent. The program of a Turing machine is represented as a diagram, and what happens next depends upon two things: what is the symbol under the head and the internal state of the machine. The action includes the machine writing a symbol and moving to the left or right or staying in place or just changing its state. Once a Turing machine enters the accept state, it simply stops.